Okay, this is what's today? Wednesday. This is our third day of class, right? Third time we've been together. And we will be finishing up unit or lesson 1 today. We left off about 1.3, so we'll go through that. And then as we get going through things, each class period, basically from 1 to about 2, we'll have more direct instruction. It may be a little bit less than that, we'll just see. And then you'll have the rest of the class time to kind of interact, have maybe some tutoring questions that you need. Or if you don't have any questions, that could be the place where you take off. We'll stop the live stream about then as well. So this class has sort of built-in tutoring. Okay. Anyone have any questions so far about the course? Okay. So let me, there was one issue with it's with the assignment that I had you do for the first day. Evidently, you can't turn anything in because I haven't put a submit button. So we're going to do that first. So that's in Canvas, because I think it's also a good thing to highlight how to turn things in. Just do a real quick review of what's on Canvas and what's on MathAS. Okay. So we're in 121. I'm going to go to Modules. And the first day activity, I'll show you what the issue is. It is available. This is what the instructor sees. If this is unpublished when it goes off, this is published, so that's why I was saying it's available. Why can't people turn things in? And I'll show you in a moment. When I go in, I get this. I'll show you when I edit. Okay. I set everything up except for submission type. The default is it won't allow you to submit anything. So I have to come in and say, let you submit online. And then I've got to choose the kind. So I'm going to let you do a text entry, which means you can just type it directly in, or you could do a file upload. So if you've already got it, you just upload it. Okay. And I apologize for anyone who tried and wasn't able to submit this. And then I just have to say save. Does anyone remember what the first day assignment was for? Good. Introductory. What were your thoughts about the first day? There's 3 questions here to kind of guide your writing. And so now you'll be able to upload or type directly into it. So I appreciate all the feedback. Because sometimes I think I set things up, but I didn't quite get it done. So that was an example. Okay. And again, there's the first day recording. There's the attendance day for the first quiz. And then what you'll start seeing is everything else that what we'll do today will be under lesson 1. There was the class presentation for day 1. There'll be another one of those. There'll be an attendance quiz for lesson 1, day 2. And these class notes kind of cover it from before. What I'd also like to do is if I didn't get anyone's copies of their notes beforehand, but if maybe today, if anybody would be willing to share their notes, what I do is I just take a quick picture. I've got an app on here that turns it to a PDF, and then I can upload it to Canvas, and people can have some written notes. So does anyone feel like they take reasonably good notes that they'd be willing to share with everybody? And they don't have to be great. I mean, we can take your name off it, or you can put your name on it, whichever, if you want publicity. Or, you'll take notes, okay. And again, you don't have to take extra notes, but just whatever you put down. If you do find yourself that you do take notes, if I take a picture of them, then that way other people, we've got the live stream, and then we've got the notes, and we've got all sorts of resources. Okay, so if you are taking notes, great. At the end, just remind me, and I'll snap a picture of somebody's notes, and maybe multiple people. We could have more than one set of notes. Okay, So that's what will be in Canvas, is sort of what's happening in class. And the other part is the Math AS. Most of you are registered for Math AS and signed up. I can tell from the grade book, and I get emails every time someone signs up. But if you aren't, you should have received an email from me with more instructions and a kind way of trying to nudge you to get signed up, because you really can't make much progress in class without being registered for the Math AS part, because it's got the online stuff. If you're having issues, we can maybe once we finish today's lesson, we'll have that time to maybe get logged in right here. I know it's a little tricky because it goes to your email, then you've got to get into your email and come back. It's hard to, most people have their email on their phone now and they forget their password. That's what my other class was having issues with. And when they sit in the classroom, the Wi-Fi doesn't work, so they don't have access. So I was having people go out of class. I was kicking them out of class so that they could sign in. I said, go out, you'll have Wi-Fi outside of class, and then we'll get registered. But if you're registered, great. If not, let's get that done today so we keep moving forward. So lesson 1 today, and then it says we may get into lesson 2, but I think what we'll do is we'll just finish up a nice strong with lesson 1, and then we'll dive firmly into lesson 2 on Monday. Yes. Yes, that's well, those are practice problems. Those are what I use in class to kind of go over. And again, they're optional. You can use them or you don't have to use them. There's media lessons as well, and those are what the videos are tied to. But I find that the practice problems are kind of nice for those who like to work through math with paper and pencil, and it's exactly what I kind of use in class. But I'll click on it, and what I do is I just kind of look here for examples, and I make sure that what we've talked about so far is in here. And if I do this, I've covered everything that needed to be covered in the videos, but maybe more briefly to the point. And we did all of this sort of stuff on Monday. And again, if you missed it, it's recorded, so you can go back. We talked about what makes a function. So just a quick review. What's the one rule that we have that determines if something's a function or not? There's input, there's output. There's a vertical line test. What does the vertical line test ensure? Yes, that each input only has one output. Good. The vertical line test is that if I put a vertical line through something, that input will only have one output. That's really what it's testing. If a vertical line touches the graph in 2 places, then it's violated the one input, one output rule. And then it's not a function, and we get to say, great, we don't have to even think about it anymore. Throw it away. Okay. Let's see. Okay. And so things like a circle, is this a function or not? No, because the vertical line touches it in 2 places, not a function. We found this little guy over here kind of goes back. It's trying to be a function, but it's not a function because of the curve back. And this one down here, the 2 points are lined up, vertical line test, not a function. Okay, so some of this first part is just, is it a function, is it not a function? Okay, and on your test, I'll do something very similar like that. Okay, then we got through these, and then we talked about increasing, decreasing, or constant. So take a look at that video if you'd like. And then we're into this section. So we got 1.3, 1.4, and maybe 1.5. I can't remember how many sections there are, but we'll take a look at these. Okay. So I'm going to write this down. And I'm starting to do the streaming a little differently. It'll either look here or it'll look over there. So I'll be switching back and forth on the stream. But you'll see I'll need to write some of the things here. We're going to come up with a function, f of x equals x plus 6. And then we've got some options here. Oh, thank you. Oops. Negative x, yeah. Little details, right? That's what math's all about, those little details. Good. Now, before we get too far, because last time I almost went through my whole class. And, I did go through my whole class, and then someone said, how do we do attendance? I said, oh yeah, the word of the day, right? So that class had to wait all the way till the end. But let's go ahead. What should be our word of the day? Showing up good enough? Who hasn't given us a word of the day yet? That would like to give us a word of the day. Cold. That's a very good. Nice and short, but accurate, right? So, cold. Describing our weather as of late. So that's our word of the day. So you'll go into the attendance quiz and you'll choose cold. Not warm, not hot, but cold, because it is cold. Awesome. That's our word of the day. And sometimes people say, well, I was in class, so I have to do something. Yeah, everyone has to trigger their attendance. So get you into Canvas, get you used to doing the online stuff. Okay. So now, how does this work? Now we remember, we talked about what does this symbol f of x mean, f of x? Is it f times x? It's a function of x. It doesn't mean times. It's really, so really f of x is the output, which we said could be, usually we use y. It's output. Oops, I don't like to do it that way. Another way we can think of it, anything inside the parentheses is input. Anything outside is output. Okay, so multiple ways. And this f is really just sort of a name for the function. But it's a complicated name because the whole symbol itself is the output, but it contains the input inside here. It's not multiplication. And one of the metaphors I've come up with is I think of it like a kangaroo. Now, why is this like a kangaroo? It's got a pouch. Good. Somebody caught on to my tricks. One of my favorite, I love stuffed animals when I was a kid. I still love them. Sorry, but I do. And one of my favorite was the Dr. Dolittle series. And I had, this I guess it wasn't Dr. Dolittle, but I had a Dr. Dolittle doll. And I had a kangaroo doll from, what's that from? Kangaroo is from Winnie the Pooh, right. Kanga and Roo. Roo was the baby. And I love that little toy because the little baby went into the pouch. And so that's what you want to think of this is it's a pouch. This is a whole one symbol, but it's got a pouch where it carries the input with it, but it's actually equal together, it's equal to the output. So it's the function, which is kind of like the mother, right? The mother tells us what to do. The function tells us what to do. In the pouch is the little baby, the little seed, the input. And when we put it all together, we get an output. Okay, so I just like to find ways to visualize things that make sense. Because I remember when I first started learning this stuff, it just seemed really hard. And then once I it took years. And then it was one day I woke up and says, it just seems so easy now. But for years, it was a struggle to work with this stuff. And that's when the kangaroo thing came, is just, this is the input, this little baby. This is the result. So when we ask for things like f of 2, we want to see what does that exactly mean. It means that the input is 2. Well, actually, before I get there, I'm going to rewrite this because there is actually an issue with using x here. To make it a little cleaner, we might write it this way. Because what is this x standing for? Why is that x there? It's the place where the input goes, right? I think back, it's over 20 years ago now, when I was teaching at Oregon State University, one of my students said it's like X marks the spot on a treasure map. It's just marking a spot where the input goes. And that was like the best explanation ever that I heard, so I stole it and I use it. Okay, it's just marking a spot, but it's so hard because we think of X as the input, as it's something, but it's really just it could have been anything. It could be a smiley face, it could be T, but it's marking a spot where when we know what's here, goes there. Make sense? And so as they ask the question, what is f of 2? Whatever's in here, where does it go? It goes over here. The right-hand side is where we do the calculations. The left-hand side, remember, is just sort of the name of the function. It's just sort of it's representing the output variable. It's this kangaroo. This 2 here is just going to stay to tell us what was the baby of the answer, right? What was the input? What was the seed? And then over here, we're going to calculate it, and we're going to get an answer. And when we're done, we've got both the input and the output on the same line, so we know when we put this in, we get this out. So now over here is where we do the math. Okay, so this just gives us -2 plus 6. We have different signs, so what do? Subtract. 6 minus 2 is 4, and it'll be a +4 because the 6 is bigger, so it's more positive than negative. We end up with a +4, and we write our final answer simply as f of 2 equals 4. And again, it may seem simple, but we'll get more complicated, but really that's all there is to it. And one of the tricks I found that works best for understanding is if you'll take this step, get rid of the x, and just make a big open space. Because isn't a big open space even better for signifying you need to put something there? Right? It's open, it needs something. So if you do that, it's going to be easier. And you're going to see when we get to composition of functions, you're going to be putting something like x plus 5 in for x. And that's, you're going to see that's really hard to do conceptually because you're going, how can I put x plus 5 in for x? But when you do it this way, it's just going to be natural. Get rid of the x's and just put some open spaces, because that's what it's going to be. And then whatever's here goes there. And it just, when you start thinking in those terms and doing it that way, it's just so much easier than trying to really, you spend too much time trying to figure out what is x. Where is x? Just get rid of x. Okay? So that's one thing. And then let's just take a look at another one, I guess. Let's take a look at this one. F of 0 is equal to what? And again, what we do is we take our model function. We're going to bring it down, but instead of putting x, we're going to put minus parentheses plus 6. Okay. What goes in the parentheses? Whatever's in the parentheses. So it's just like monkey see, monkey do. That brings you to my second favorite stuffed animal. What was the monkey's name? What was the man with the yellow hat? You remember reading those books? Anybody read those books? The man with the yellow hat, and he had a monkey. Curious George, yeah, Curious George. Again, one of my favorites. I had a little Curious George stuffed animal. Always used to talk to him too. Now this one, what I want to focus on here, when x is 0, where are we? It's a little ahead of our game, but when x is 0, where are we? Origin. So yes, we are here, but can we go left or right now? We're on the vertical axis. Yes, because if we go left or right, x is going to change from 0. But if we go up or down, x actually doesn't change. So this is a very important point. When x is 0, where we are is we are on the vertical axis. This is our vertical intercept. This is a important part because it's really our starting value. So one of the things in math, we're always looking for the vertical intercept. The way we find the vertical intercept is simply we put in 0 for x. Because if we put in 0 for x, where does y have to be? Well, the point has to be here. Y could be up or down, but the point has to be on the vertical intercept. It is. And if x is not 0, we're over here to the right or we're over here to the left. So that's the only way we can have a vertical intercept is x has to be 0. Once you get that, the rest of math just makes so much more sense. Because that's when you get into calculus, you'll be doing that, but you just start making things equal to 0 and you just start doing it, but you're not quite sure. When we make x equal to 0, we're a vertical intercept, and you were looking, what would the horizontal intercept be? It'd be 0 for what? Y. when x is 0, we're vertical. When y is 0, we're horizontal intercept. And those are two of the main things in math all the way through calculus and beyond. But when we get, the calculus, we get all caught up in all this other thing, we forget sort of the simple things. And they'll say, find the vertical intercept. You go, oh, shoot, how do I do that? Put in 0 for x. How do I find the horizontal intercept? Put in 0 for y. That's why we do it. But I work with students a lot, and they just start putting in 0 for x, for something, because they remember to put 0 in for something, but they don't remember why they're doing it. And the reason we can do that is when we want the horizontal intercept, y has to be 0. When we want the vertical intercept, x has to be 0. So that's what we do. Okay. So anyway, we could finish working this out. And again, remember, the left-hand side, really nothing's going to happen to this. This is just a nice, friendly kangaroo. You don't want to mess with it because they can box and they could hurt you. So you just leave it alone. Don't even get near it. But on this side, you do all the math. Negative 0, which is just sort of 0, right? 0 could actually, it's kind of cool. It can be negative or positive. 0 plus 6, 6. Okay? Simple, right? So that's the functions. I give you the input, find the output. Is there another way I could write this? This is called function notation. And there's another type of notation that we're going to use called ordered pair. What does an ordered pair look like? An x and y with parentheses. Yeah, I've got one friend teaches here. He says, so sometimes he sees this, he calls that a naked ordered pair. It doesn't have its clothes on. So make sure we have no naked ordered pairs. Make sure they got their clothes on. Parentheses. So yeah, that's just, it means exactly the same thing. That says, oops, I was talking, I jumped down to the wrong problem, right? So we'll do this in order. Sorry, people. So 2, 4, right? 2, 4, and this one, 0, 6. Okay. So two ways of writing these function notation with the F symbol or G symbol, G of something. And we've got input, we've got output, or ordered pair, x comma y. We've got input, we got output. Okay? And that's really all there is to it. Okay? But sometimes, so don't get too hung up, but you don't have to memorize ordered pairs definition or anything, but when you see ordered pair, just know what they're looking for. When you see function notation, know that that's what this is. Okay? You don't have to define it, you just have to be able to use it. Okay. Good. So far, so good? You have just learned 50% of what you're going to be asked to do in this class. We will give you an input and ask you to find an output. Now, it might get a little more complicated, but that's basically it. That's pretty much half of the class. Or maybe it's only 45%, but pretty close to that, okay? And I think if we get down, see, here's another example. Here's another example. Let's look at this one. Let's look at either, well, 12 or 13. I think we could look at either one of these. Oops, sorry, folks that are online, you can't see it. So now I'll switch over here. 12 or 13. We've got 12 A, B, or C, and 13 so forth and so forth. Which one would you like to take a look at? 12. Which letter would you like to start with? B. Good. I always like to start in the middle, so that's good. So we're going to take a look at number 12, or number 12, letter B. Okay, so I'm going to go down a little bit further. I'll write it down. But I'll switch the folks over here. Online, we'll switch back to the board. So we're going to look at number 12, which is h of c equals 2c squared minus 3c plus 4. And again, just to make everything consistent on what's going to happen, they're not using x, but they're, so it doesn't matter that they use c. How can we rewrite this so it is ready to get inputs. What if we wrote this as h of parentheses squared minus 3 parentheses plus 4. Doesn't that look more like a function ready to get some inputs? And then you don't have to worry about that c, because, you know, and it's almost rude, isn't it, to plug something into c? C's there first. Why do we have to replace c with something? Now it's like we're ready for something. And whatever goes here, where does it go? Here and here. It's just natural. What this open space is one, we only can put in one thing at a time. And so whatever's in there goes in both places. There's two places for that input to go. Okay? And now it's perfectly ready. And it may seem like a simple thing and it looks like a little extra writing, but you'll just be amazed if you have, you know, if you don't have problems with this, fine. But if you've had a little bit of struggles of where to put things, you'll find that it just really flows together now. It's just kind of like, well, there's open spaces, so whatever's in there goes there. So the B question, we'll put that, has us putting what, a 3 in here. So since there's a 3 in here, where else does it need to go? Here and here. And it's all set up. So we just put that in there. Now we do the math on the right-hand side. The left-hand side is the kangaroo. We just let him come down. And the kangaroo is going to tell us that this function has a certain value, the output, when the input's 3. Okay, so this just keeps coming down. And we do the math. Or we get a nice calculator that we just plug it all into and it takes care of it, because we got to do order of operations. I'll kind of do step by step. What usually do we do first? Exponents, or parentheses, but there's nothing inside to do, so we do the exponent first. So this becomes 2 times 9, 3. And then while we're at it, let's go, since that's taken care of, 3 times 3, 9 plus 4. Now, can we take 9 minus 9? No, because we got to multiply first. But do we get 18 minus 9 plus 4? 18 minus 9 is 9, plus 4 is 13. So h of 3 is 13. Okay? Again, another half, a little more complicated, and we will have a whole section on these type of questions, which are called quadratics. Okay, these are quadratic formula and stuff, and we'll do all sorts of stuff with this. But for now, all we're doing is input, output. And again, ordered pair, 3, 13. Let's come back here, and I think we come down here, and now this is where you're going to see, look at that 14, let's look at C. You could actually look at any of them, but especially 14C seems to be something that causes some problems. Okay, but it's not going to cause us any problems, is it? Because we're going to come back here with what we already started. We're going to take our format, right, take this out of the way, because it's dealing with the same thing. F of x is x minus 6. Take this out and this out. If we do that, what does C tell us to put in the parentheses here? X minus 3. So what do we put in this parentheses? X minus 3. Now, when I've seen students try to do that directly, they'll try to use this, they'll have x minus 3, but when they do it over here, a lot of times what I'll see is a minus, they'll put x minus 3 plus 6. They're just trying to put it in for the x, but is that correct? Not really, because what we have, you're going to see, we're going to distribute this, and it's not going to be quite right. And so if you don't set it up with the parentheses, you get where it's kind of hard sometimes to figure out what's the right thing to do. But when you put the parentheses, what's inside this one goes inside that one. And now we know how to handle parentheses, right? Order of operations says do the parentheses first. So we come to these parentheses, what's the first thing we need to do? Distribute the negative, see? And so we follow through with this. This is f x minus 3. This will distribute to both of these, so we get a minus x plus 3. And notice over here, if we didn't have the parentheses, you're subtracting 3 when actually we're going to add 3. Okay, so if you put those parentheses, it's like all the problems that usually happen with this sort of thing disappear immediately in one step just by putting parentheses. Okay, just by writing it out like this. Plus 6. And then now we work it out. And again, the left-hand side is the kangaroo. You don't want to touch it. Just let it be. This side, we can combine some like terms, right? So this becomes minus x plus 9. Sort of a new function. The other part of this is that students will look at this and they feel uncomfortable because we didn't end up with a number. In algebra, oftentimes, when we're working with a function, if we've got a variable, we may just be changing the variable or what it is. We're sort of adjusting the function. So we get a new function out of it, not an answer, not a number. And sometimes that's good because now there's nothing to do. We don't have to combine these because they're not like terms. We're done. Okay, so that's the other part. But again, it's supposed to be easy, but the difficulty is you want to do something with this because you think you're supposed to have an answer. And the weird part is we could actually write this as an ordered pair as well. X minus 3 comma minus x plus 9. That's kind of a weird ordered pair. But when you get into calculus, you start seeing stuff like this and more maybe Calc 2 or 3 or math theory and stuff. So don't worry about it. We won't throw that at you. But this is function notation, right? This would be ordered pair notation. This is the input. That's the output. So it becomes harder to talk about this is the x and this is the y when they have x as part of it. But it really is. This is the input. That's the output. And you do that when you get into more advanced math. But if you learn this early on, putting the parentheses, input, output, as you get to more complicated things, you just see that it's just, you're dealing with variables and sometimes variables of variables, and it's sometimes hard to get your grasp on it, but if you get these techniques, it'll be easy to work with them. And then you try to understand them later, much later. Sometimes it's okay, but okay. But this is more of an advanced problem. This is called really composition of functions. But you're going to see if you follow through with this way, it'll take care of itself. It'll be nice and clear for you. All of those other ones work that way. Okay, and they've got a few others for you to try. Okay, so now I want to take a look here. This gives us almost to the other 50% of what we're going to do. So if I give you an input, we put it into the parentheses, do the calculation, we get an output. I'm going to take a look at B. This is what? It's a new function, so we can come back. We're going to look at the B part of this one, and that will help us focus on the other 50% of this class. And that's give you an output, you have to find the input. Okay, so I'm going to switch back over to the board. And we'll take this function, f of x equals 3x minus 6. And we'll look at the b part. It's saying basically what is x if f of x equals 3. Okay. Now this is the one place where we're not going to rewrite it and take the x out, because what are we looking for? We're looking for x. So if we get rid of x, then how are we ever going to find it, right? So in this case, we're going to We're going to leave x there because that's what we want to find. So where does this 3 go, though? Is x 3? We don't, right. So we can't put this 3 in for x. What do we put it in for? Well, 3 is the kangaroo. 3 is the output. So what we're going to do is this 3 replaces the whole f of x. It's the answer. And then we do our algebra to solve for x. So this is where actually probably more of the work is. This is where we really think of algebra. So far, we've really kind of just been doing arithmetic. We plug in a number, do the math, and we get our answer. In this case, we're going to put the 3 in for f of x. So we get 3 equals 3x minus 6. Okay? So when I give you the output, you need to find the input, so we'll leave the input in there. We'll leave x alone. We'll put the answer. And notice now we've got to work with both sides of the equation so that we can isolate x, get it by itself. Okay? And this is where we're now going to be working in the world of opposites. So how many of you were rebellious as teenagers? Whatever your mother told you to do, you did the opposite. Good, you'll do well in this class. Okay, you'll do well on this part. I was kind of back and forth. I'd feel guilty when I do it, but I feel like, yeah, I'm a rebel without a cause. So, but if you'll do this, you do the opposite of what you're told, you're going to be great in solving. Over here, you have to do exactly what you're told because that's how it works here. So here, we've got this x, and we want to get it by itself. So what do we do first? Add 6. So not only do we do the backwards, instead of subtracting 6, we're going to add 6. We also are going in opposite order of operations. We're not doing the multiplication first. We're doing the addition first, which we're supposed to do last. But again, we're rebels. We always do everything backwards and wrong. Okay, backwards and wrong. So opposite of adding 6 or subtracting 6 is adding 6. But we're sort of good because we do it to both sides, and that's what allows us. Because an equation, what is an equation? It's perfect balance. We got a perfect balance when we have it, because both sides are equal. Both sides are the same. And so if we've got something where both sides are the same, how do we keep both sides the same? Well, if you make a change here, you make that same change on the other side, and it stays the same. That's the whole process here. Okay? So we're going to add 6 to both sides, and that keeps the balance the same. On the right side, it eliminates one of these terms. This becomes 0, and this becomes 9. You could put plus 0, but again, what we're going to find in algebra, when you add 0, it's nothing, so that's why it's disappearing. Algebra is really about making 0 and making 1s. Making 0s and making 1s, two of my favorite numbers. You can make a 0 by adding the opposite. How do we make a 1? Dividing by the same thing, because anything divided by itself is always 1. So that's the keys that we're doing, is if we can get this 3 turned into a 1, then we've got our 1x. So then what we do is we divide by 3, but whatever we do to one side, we do the same thing to the other to keep that balance in life, keep the equilibrium. And our world would be just such a nicer place if that always happened. You give some money to the rich people, you give some money to the poor people. Actually, you need to be a little unbalanced first. But, you know, if our world was more balanced, right, everybody would be balanced, equal, and we keep it balanced and equal, it could work. It could really work. So this becomes 1, 9 divided by 3. My goodness, x is 3. We didn't know it was at the beginning, and we said it wasn't, but it was. That sometimes happens. And so how can we write our final answer with function notation? Sort of, but we don't have to say f of x. We can say f of, because 3, because we know what x is now. So it looks kind of weird, but f of 3 equals 3. So it tells us when you plug in 3, you get it right back. It's kind of an interesting, it's probably a very unique piece, but yeah, put 3 in. 3 times 3 is 9. 9 minus 6 is 3, so we could check it. Okay? 3 comma 3. And that's the other half of what we have you doing throughout this course. We give you outputs, ask you to find the inputs. And again, we'll do some of these by hand. As we go down the road, we'll also show you how to use the graphing calculator to do this. It's basically finding an intersection. We'll be able to do it. We'll graph the function. We'll graph the y equals. We'll see that that becomes a horizontal line at 3. The function intersects it. We find that intersection point. We have our answer. So that's one of the ways we're going to do a lot of the math here. We could do the same thing with the given the input, find the output. That's a little bit easier. But you'll see every time we have two ways of doing things. One is called evaluating. They give us the input, we find the output. That's a sort of a straightforward operation. The other one is called solving. They give us the output. We have to find the input. It's a little trickier, but we'll get there. Okay? We'll look at many different techniques. But again, that's all we're going to ask you to do. If you get down just those two things, you got everything. And everything else is like find the vertical intercept. Okay, plug in 0 for x, we'll get that. So that's really what they're doing when they say find the vertical intercept. They are giving us the input, and they're telling us the input is x equals 0. They'll ask for a horizontal intercept. What are they telling us? They're telling us the output is 0. And again, we're just doing this. So there'll be things that doesn't seem like you go, little crow, there's actually a lot more things we're doing. But if you break it down, everything is, I will give you an input, give me the output, or I will give you the output, you give me the input. All of the questions we face will be that. Some of the questions will talk about the functions and what they end up looking like. Sure, that's it. But to get that, you have to understand input and output. That's all you, once you understand that part, everything else pretty much comes into play. When I ask you for the domain, what am I asking you about? We used that word before. Domain relates to what? Domain is, I'm asking you about the input. Domain is what are all possible inputs. So we're talking about the input part. When I ask you about the range of something, what are possible outputs? You see, that's the key to this. The thing is, Math 150 is going to be the same. It's much like this, and even in calculus and beyond. You're dealing with inputs and outputs. Functions will be the wrap around all your mathematics from here on out until you get really advanced, and then you could do non-function mathematics, and then you can come help me because it's real cool stuff. You can get like to multi-dimensional stuff, multivariable stuff. I kind of stopped. I said, that door is not the door I need to open. But some of you will, maybe, if you want. Okay, so far so good? Okay. And again, they throw in things with fractions. What I like to do when I'm first learning something is I like to skip fractions because it just seems more complicated. So some people like to throw it in. It's just, if I can understand it with integer values, then I'll understand the concept. Fractions is no different. The other way you could do it is, these are actually fairly nice fractions. You could turn the fractions to decimals. So however you want to work at that, but don't worry too much. Again, now we've done the hard stuff, input, output. Let's do the easy stuff. But it might not look easy when you first do it. And again, I apologize for those at home who haven't been watching because I didn't have this up. So now, let's look at the A part. What is this asking? What does this 7 represent? It's an input. Where do we look for an input on a table of values? In the top. So when we find the 7, how do we find the output? Just look below there. That's it. K of 7 equals -7. Okay. I've got to figure out how to get my writing thing to work in here. But this, yeah, this is equal to -7. So K of 7 equals -7. Just a lookup. It's just looking something up in a table. Okay. K of -3, regular 7, positive 7. So we look it up here. Here's the -3. We go down. There's its partner. That's all we're looking up. Okay. So forth and so on. So now let's go for the advanced stuff. Okay, we just got this down. So when I do the A part, I'm looking for x when f of x equals -12. So -12 is what? It's output. How do I look up output? From the basement. It's always reversed. Remember, when I give input, I go to the top and I look down. So if I've got output, I go to the bottom and I look up. Everything's reversed. That's all it is. So I find my -12 right here at the output, and the input must be 0. Okay, that's all there is to it. Looking it up in a table. Okay, but this is another part of it. Sometimes we give you the values this way. We're going to also use the graphing calculator. Sometimes we'll use the graphing calculator. We'll have it make a table of values, and then we can just find our values this way. It doesn't feel like we're doing math because we didn't calculate anything, but this is mathematics. Okay, this is part of mathematics. Okay, so we got an ordered pair 0, -12. The -4, where are we looking that up? The top. Okay, so that tells us go to the top, then look down, -4, 3. Okay, and we always throw a confusing one that, you know, there's a number that's in the top and the bottom, and which one do you have to look up? But again, just be careful, just be cognizant of what you're looking for, whether you have input or output. That's all. There's only two things a number can be. It's either input or it's output. I guess a third thing, it could be part of the equation, right? But what we deal with is input or output. And then most of the time we know the function, or we have ways to find it. So far, so good? Awesome. Number 3. How do we find out these values when we have a graph? Okay, so for this one, we read question A. So they give us this graph. This graph defines the function. It defines it with points. There's no formula. There's no table of values, but there is a graph with points. Okay, so we're asked here in A to find x if f of x equals 4. So what is 4? It is output. It's outside of the parentheses. It's output. How do we look up output? On the vertical axis. So we come along here. We're looking here. There's the 4. And then what are we looking for? We're looking for what is the x value, because really we know the y value. The y value is 4. So here's the point. The x value here is 0. Because that's a vertical intercept, right? We're right on, we never left the y-axis. So our answer here is 0, 4. Okay. So let me take down. So this is 20A. The 4 is output. And they ask you these questions. You know, are you finding input, output? So if they give us the output, obviously we're going to be finding input. And then we write the ordered pair, and there we go. When they give us the input, how do we find that? Let's switch back over. Let's see. So -2, f of -2, where do we look that up? Along the horizontal, right? Here's -2. And then where do we find the y value that goes with -2? We go up or down until we hit the point. In this case, we have to go up, and it's going to be 3. The y is 3, the x is -2, the y is 3. And again, you're going to see, so a lot of times we'll be doing this. We'll graph a function, and we'll use our graphing calculator to do these things. But this is another way of doing math. No calculations are being done, but switch back over. It is math. It is looking up in a table or a graph so we were given input and we were finding output, and then we get an ordered pair. Excellent. And that's all there is to it. Okay, so we do it with equations. We can do it. That's the harder part. We have to do the calculations and such. Table of values, it's just looking up values. Graphs, it's really just looking up values, but we have to, it's a little more difficult because we have to know, are we looking on the horizontal or the vertical axis, and then once we got that point, are we going left or right or up or down? So it will challenge some of us spatially because some of us are inclined to go the opposite way. And you would know this if you ever try to dance with me. When we're supposed to go left, I go right. I step on my partner's feet a lot, so that not many people will dance with me a second time. Even my wife will, but you know. So some of us we know that, right? If you're one of those people, you walk down, you see someone going, have you done this, the dance thing? You go to the left, they go to the left, and you're trying to make it so that you don't bump into each other, but it's just like you're doing this back and forth. That's part of it. You're both trying to think to get out of each other's way, but you start mimicking each other. And so this is a part of thinking that we have to take our time with, and once you do, you'll get it down, and you'll be perfectly fine with it. Okay. We're good, we're good. Again, just more graphs to look up, more tables. Now they want us to use a graphing calculator, and I'll do this hopefully next time. How many of you have used a graphing calculator before? A few of you. How many have never used one? Okay. So this will be a good one. Maybe what we'll do is we'll take a break, because the reason I've got one on my computer, but when I put it on the other screen, it gets so big you can't see it. So I've got to work on what's the deal with the software to make it work better. But I do have a graphing calculator, and what we can do is maybe when we break off, if you want to say, I'll show you a few things, maybe hand on hand, because sometimes that's helpful. Okay, but actually in this first part we're okay. It's more building for what we're going to do in the next few units. Okay, so like I said, we'd go till about 2, domain and range. Okay, that's that whole stuff. It's not as important, but sort of important. And then applications of functions is nothing new, but just how they're applied. So I'll let you kind of go through that. But let's do a discussion of domain and range. Okay, so we'll look at a few examples. What is domain? What is range? That's that. Here we are. Domain and range. So when we are talking about the domain, what are we talking about? Input, exactly. And more fully, we're talking about what are all possible inputs. Okay, what are all the possible inputs? When we're talking about range, what are we talking about? The outputs. What are all the possible outputs? Okay, so we've got to look at this, number 24. We'll take a look at a couple of these examples. So if I look at example, let's see, which one do you want to do? We could do A, B, or C. They're both going to end up kind of the same. A. Okay, let's go, because there's more to it, right? It looks like it'll. So A, we're given that function, and what part of it is the domain? All the inputs. So when they give us points like that, all we have to do is we use these things called curly braces because those are used for sets. It's the set of all the x values. I just start writing down the x values. 3, 5, 7, 9, 11, and 13. Is 10 in the domain? No, so we don't put it down. Is 5.6 in the domain? No, we don't put it down. This is the domain. This is all the possible inputs. We go to the possible outputs. We do the same thing. So the range is going to be curly braces, and then we just start listing all the range. Now the thing with the range, it's possible that we could have two values that are the same and it's still a function, right? So if we have two values that are the same, we only have to write it once. The other thing we like to do with the range is put it in order from smallest to largest. But sometimes that's easier said than done. So what I like to do is I just go ahead and start writing them down, and then if I need to, I can reorder them. It's not really a big deal. It's not wrong if it's not in order, but it could oftentimes be that they're different orders. So -2, -1, 8. We come back to -2. Do I need to write that -2 again? No, because I've already got it. So I'll just skip it. And then there's a 4. And then a -2, which I don't need. So I could list that as the range. Or if I look at the answers in the back of the book or wherever they are, I might see it as -2, -1, 4, 8. But I don't really care whether it's in order or not.
So if you list them, it doesn't have to be from the smallest to the largest?
Not really.
They'll be correct.
Math AS might mark you wrong. Sometimes it does, but sometimes it'll let it go. It just depends on how it was programmed. And technically, it's right. It's just a list of sets, but it's just sort of a convention to list things from smallest to largest. But it's also sometimes tedious. Okay. I'm interested more that you got the concept of what the range is, the concept of what the domain is. Okay. So if they give us a set of values, it's just all the x values in the domain, all the x values in the y. That's it. Okay. But when we come back here, again, this is sort of similar. So it's just listing x and y values, but it's listing them as a table. But it's going to be the same thing. We list all the x's and then all the y's. If there's a repeat in the y's, we don't have to list them again. We just have to list it one time. Shouldn't be a repeat in the x's, otherwise we might have a problem with it even being a function. So again, we could do this, list the domain and range, just like we did above. But what I want to do is I want to get to the graphs, because this is where it gets maybe a little more complicated, and there's two different ways to write this. So we've got a line here. What is that going to mean about the domain? Can we just start listing like 0, 1, 2, 3? One end to the other end, exactly. And it's everything in between. So you'll see between -2 and -1, it's not what we call discrete. This is what we call continuous. It takes on all these values. We can't list them all. There's an infinite number of values. So we list the end, the two endpoints. Okay. Now, does this thing even have an endpoint? Does it stop here? The window stops here, but the indication, since there's not a point there, is that it keeps going. So if it keeps going, where would it start? Very good, very good. So this is where we're going to conceptualize all graphs. Negative infinity here, positive infinity here, positive infinity in the y direction, negative infinity in the y direction there. Okay, and so if they don't have an endpoint, those are going to become sort of the endpoints. And we'll look at some that do have endpoints, and we'll talk about it. But this one is kind of going like this, and we can kind of see it, since it doesn't say it ends, it goes in both directions. So the domain, two ways of writing this. we're going to use inequality notation. And so we know we're talking about the input, which is x. So x is going between negative infinity and positive infinity. So we write it that way. That's inequality notation. Notice I had to erase the equal part because technically you can never get to infinity. But I hear it's a pretty nice place if you can never get there. Anybody been there? No, not yet. We're trying. But if we could get there, it's a great place. Infinite, abundance. As much soda or chips, whatever you like to eat, you can eat it all there. Okay, negative infinity, positive infinity. So that's one way. The other is called interval notation. With an interval, all we're doing is we're listing the endpoints, and then we're using either parentheses or brackets depending upon whether they're included or not included. So what are the endpoints of this domain? With parentheses, because you can't get to infinity. If we could, we'd put brackets, but so it's parentheses, negative infinity, comma, infinity. So notice it just sort of takes the x out of the middle, and that's our domain, everything.
What do you say we can use brackets?
Brackets, I'll show you on the next example. So brackets will come in if we have an endpoint and that endpoint is included. Okay, then we'll use brackets. But otherwise, we're going to use parentheses. And we can see the range will be the same thing because it's going down this way and going up that way. So it'll eventually, it's shooting off there. So the range is also going to look exactly like this, except we might list the range as minus infinity is less than f of x, which is less than positive infinity. Or we could just use interval notation, minus infinity to infinity. Okay, so in this case, the domain and range are exactly the same. Everything. Okay, so far so good? Okay. Almost there. And then we're going to look at, so here's one. This is a good one. Where we could take a look at endpoints. That's a good one too. Let me see if I even got a better one. Let's take a look at this one, because this one encompasses everything. Okay. So we want to look at this. What's the domain? What's the range? Okay. So when we're thinking of domain, again, we're thinking of the x value. So we're thinking, coming from the left, where does the graph start? First time I start to see the graph is at -6. Okay. Is -6 included? No, it's got a donut hole, so it's where it starts, but it's not included. Okay. And I'll explain that. Let me explain it right now, because I see a few looks like, how do we know if it's included or not, and what does that even mean? Okay, let's talk about grades. Let's take this out. So I might do something like this. 90 to 100 is an A. 80 to 90 is a B. Okay. What if you got exactly 90? What is that telling you? Are you going to get a B or are you going to get an A? Because it's in both of them. Well, if you got 90, which one would you like it to be? Hey. So the way we're going to write this is, if you've got exactly 90 to 100, you're going to get the A. And maybe we can't get above there. But this one is going to be from 80 up into 90, but not including 90. 90 is not included in the B range. Because if you got 90, that's up in the A range. Okay, so this might look like a graph of let's see, here's 80, here's 90. This is B, this is A, this is 90. So if these are somehow your input of your scores, you're between 80, including 80, all the way up to 90, but not including 90, you'll get a B. But if you have 90 exactly, you're up into the A range. Okay, so that's where the open circle, closed circle comes from, is typically there's some values in mathematics that there's sort of an overlap, sort of a change. Oftentimes cell phone plans used to be like this. You could use up to 500 minutes. Now they're all unlimited, maybe not always, but you use up to 500 minutes, and after 500 minutes they start charging you at different rates and stuff. And so that's where that is. It's that overlap area. And what happens exactly at 500? Well, you have to choose. You either get charged off the old plan or the new plan. And so this is how we're going to indicate it. An open circle means, nope, not part of that group. You have to go to the next one. Okay. And so when we look at this graph here, we've got this down and then this. Okay. So the -6 is not included. We keep going until we hit this value here. And what value is that? -1. Is it included? It is, because it's a solid dot. So we can indicate it this way. What kind of notation is this called? Interval. Okay, so just get used to using it. That's interval notation. And we could also use inequality notation. And for that, when we put the x in the middle, here's -6, here's -1. This is a less than, oops, not equal to, just less than. This one, less than or equal to. Okay, so those are equivalent ways of writing the same thing. And again, this is when we have a domain that includes all the stuff in the middle.
So when you were doing that, and the point went down to -3, that didn't include it. It's when they close this off at the dot, that's what we count as the -1, you said, right? So that
Yes.
was the end of it.
Yes, and what we're looking for, because we're looking for domain, we're looking just left to right. The start to the end, left to right. We're going to get into what you're talking about, getting down to -3. That's going to be included in the range, because the range we look from bottom to top. Okay, so that's the key part. When you're looking for domain, all you're focusing on is where does it start on the left, where does it end on the right. We don't really care what happens in the middle until we get to the range, because it might affect the range. Okay, so that's domain, left to right. Okay, range is, since it's y values, we want to think from bottom to top. So it's the same thing. What I used to do, or what I like to do, is if it's a piece of paper, I just turn it sideways, and then it's like thinking about range again, left to right. But it's hard to turn the screen around. But so we'll think through this. I don't have it drawn quite right. This should be a little bit higher. So the x-axis is kind of like here. And so now when we're looking for range, we come from the bottom until we hit the graph. What's the first value we hit? That's the negative, that's a y value of -3. That's where it begins for us. So when we start to talk about range, again, bottom to top, we're going to start at -3. And is that included? Good. It is because it doesn't have a solid dot or an open dot, but if it's not open, it's closed. It's just sort of, if they don't put an open dot, we will assume it's a closed dot. So good, it is included. So -3 is included. We'll put a bracket. And then where is the top of the function? We keep going until we get to the very top. Good, it's the y value we're looking at, which happens to be +5 up here. Okay. Good, because that is an open circle. So we got a parentheses. Okay. That's interval notation. What is inequality notation? Equal to, right? Because of this, it's less than or equal to. This side, just less than. Not equal to because it's open circle. Okay. The direction of these inequalities is always the same because we list them from smallest to largest. That's the advantage we get when we do list it from smallest to largest. Because I don't know about you, these symbols are hard on my thinking because you switch them and then they mean the other, you know. It's just, you really have, I have to be careful. I don't know. It's just, and if I work with them too much, I get a headache, so I don't like them. I like this sort of notation because it's endpoint to endpoint and everything in between, and it just makes more sense. Okay, that's what you'll find in math, especially as you go on into calculus. One of the hardest things for me was there's two people who came up with calculus about the same time. One guy was named Sir Isaac Newton, a British guy, and another guy was it Descartes? I can't remember. Sorry, any of my colleagues that are watching this, but I forget who made up the other one. But he was a German guy, and he had different notations. So the thing is when you start to learn calculus, oftentimes you will learn two different notations for the same thing. One made sense to me, the other didn't make sense. So I sort of understood things, but when a question came out and used the other notation that I wasn't familiar with, I had trouble until I learned how to change that notation into the one I could work with. Okay, but sometimes in math, that's all it is there's two different symbol systems for exactly the same thing, and one makes sense to us and one doesn't. And eventually we learn how to use both if we're going to be a mathematician. If we're not, then we just learn enough to get by and learn enough to apply it. And that's the thing is sometimes in business school they use the math differently. Even in engineers, when I was at Oregon State, the engineering department was going to basically fire the math department. It says we will teach our own math classes because you don't teach our engineers math the way we want them to do math. And they said, oh, whatever. And then they were getting serious, and they said, oh, okay, we'll adjust. We'll teach. How do you want us to teach math? We'll teach it so you're engineers, because engineering is a big part of the math program, right? And they didn't want the engineering program to teach all their own math classes. So, but it's just sometimes that's what the thing with math is. It's hard to understand simply because a certain symbol system, a way is being done, but sometimes there's a different way to do it that might be more efficient and easier. It's just that we're stuck in the historical way of doing things. Does that feel good about domain and range? Again, this is about as complicated as it gets. And what we're going to do is all these concepts we're doing, we're going to re-explore them again in terms of particular functions. And the first big one I think that we do, we go to exponentials first. I can't remember. It might be linears. Whatever, we'll study a function type, a function family, either linears or exponentials. I think it's linear now that I'm thinking about it. We'll study it under linear, and then we'll study them again, how they apply for exponentials, and then we'll study them again as how it applies to quadratics, and then we'll use it again. So we're using it in like 4 different settings. So all of this is just kind of foundational stuff. Don't worry about that it makes perfect sense right now, because it's really not supposed to. It's just it's a foundation we're going to build on. And even this first test, if you don't do as well as you'd like, I guarantee you, if you just keep going forward with the other units, we'll come back to this later, and it'll just seem like a piece of cake. But you just have to see this stuff again and again, and under special circumstances, then it makes a lot more sense. Okay, right now it's all general stuff, but that's where it is. And then when you get into lesson or 1.5, so this is more of the practice problems, it's going to be applications, and so they give you word problems, and then they talk about domain and range. I'll give you a chance to kind of look through those on your own. We'll get a chance to deal with them also again when we get into lessons 2 and 3, so I'm not too worried. They're not going to go away. Applications are best if we take a look at them within a family of functions. So when we look at linear functions, we'll look at a lot of examples. When we go look at exponential functions, we'll look at a lot of examples that all make sense together, and that's a better way to do it. If you go looking at it here, it's a mix of different types of functions, and of course it's going to be confusing because they're jumping around on you. So don't worry too much about that part. Okay. Went about 15 minutes over, but that's okay, I guess. How's everyone? Any questions, concerns? Everything going? Yes. Go over what? The symbols. Okay. This one or the line? Okay. So this, yeah, this part comes from the equal sign, so it means, so when I do this one, this means included. And again, it'll be a bracket either direction, and it comes from a solid dot. This one over here means not included, and it will get associated with a parentheses and an open dot. And when you take your first exam, you get a page of notes. So you don't have to memorize this stuff, but have little note cards or stuff. That's what I did. Is for me, what worked best is those 4x6 note cards because they, the cardstock held up pretty good, and you could get. And I'd do it sideways so I could get a lot of notes, and I would just take them. And what I found is, as I do my homework, if I like stuff like this, I would list down, and as I did my homework, I'd look at them. So I wouldn't try to memorize things because I found that somehow didn't work for me. But as I worked homework and I looked, eventually I wouldn't need my cards anymore. So I remembered things, but I didn't try to remember them. It just happened. But I always had to have them out. And sometimes I just, was like, where's my cards? I'm going to go crazy if I don't have my cards. But once I had my cards, I felt relaxed and I knew I had everything I needed. And then when it came time for tests, when I had professors that would let me use notes, I had most of my notes ready and I knew what I needed and what I didn't. So then I would transfer my note cards to a page or whatever they allowed us to use for the notes, and I was good. But I did that because I would see those same notes again and again, and I wouldn't have to go back and look up in the book. Here we're looking up in an electronic book. So yeah, make some notes here. And does that help?
Yeah.
Okay, so it's just like, I gotta see it. And then when you see it again and again and again, after about the 500th time, you start remembering it. It's just kind of natural, and that'll work. Okay, what else? Yes?
When you're doing your equality notation,
Uh-huh.
like you have -6 and then your sign and then the X, when you're doing a problem, you put in the F of X and then the other quantity, or if it was G of X or H of X, that has to.
Yeah, if we're talking about the range, yeah, that part is always in the middle. So this is our symbol. We could have put Y here as well. But since we're in the chapter on functions, we're using function, but we could have just as easily put Y in the middle there. So it really is just saying Y is in between these two values. X is between these two values. So X is left to right, Y is bottom to top. And sort of, you could take a graph and basically draw a little box around it, nice tight box, and you'll have the left to right box is your domain, the bottom to top of the box is your range. Awesome. Okay. Well, keep up the great progress. Yes. Oh, no, you're just, okay. We'll stop the stream now. Remember our word of the day. It's cold out there, so bundle up, wear a jacket, a scarf, gloves, whatever you need. Don't get sick. And we'll just keep moving on. Sometime today, I've got a research thing I'm a part of, so it might not happen, and then I've got a class at 5, but I'll try to get it in sometime today. If it might be later tonight after I get done, but it will be in there sometime. So yes.